So today I wanted to talk about infinity. Now, infinity can't be all talked about or mentioned or explained really in just one short little video. So I'm just going to start off with infinity and multiple parts to this. And yeah, so when we talk about infinity, we first have to talk about how to count. And now we know the conventional way of counting numbers, 1, 2, 3, 4, 5, etc., etc., etc. We can count that. We know positive, negative, 0. We can do decimals. But what's hard is with infinity, we can't really count to infinity, right? Because once you stop, you haven't reached it, because infinity really is unreachable. You can count all the way until, until the morning's light, but you still wouldn't get infinity. And so it's a weird thing. And infinity isn't a number. It's just, yeah. So we have to think about how can we talk about counting infinity when we really can't count the conventional way that we know how to count. When I, say our fingers, 5 fingers here. All right. Unless you had a carpenter accident, then I guess you don't. I shouldn't joke about that. Anyway, so counting. Well, how do I know the 5 fingers on this hand and the 5 fingers on this hand have the same amount? Right now, I can say, okay, I can count 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yes, they're the same. They both have 5. But what if I couldn't count? Didn't know how to count these numbers. And a way I could do it is just pair up my thumb to my other thumb, together. And then the pointer fingers together, and then the ring fingers together, or the middle fingers and the ring fingers and the pinkies together. And so I would know that my right hand has the same number of fingers as my left hand, but yet I still don't know the size of them. Now, if I just count I know the size of my right hand's 5, and I can show that it's the same pairing, or I can show a 1-to-1 correspondence between my right and my left hand, I then can conclude my left hand must have the same size finger. Now, I wonder if the video image, this looks like my right, but this is my left from my position. And so we can say that these two hands have the same amount of fingers, not by necessarily counting them, but showing that they have a 1-to-1 correspondence. And that's really what a 1-to-1 correspondence is. You can show a pairing, a matching of every one element from one set to every element of another set. And now that sounds kind of technical jargon right now, but that's really is the elements. So if my first set, my set of numbers or letters or elements, I just make my fingers. I can make it A, B, C, D, E. That's my first set, and it has a size, a cardinality. Here's another term. Cardinality is a size, basically, of it. A cardinality of 5. There's 5 elements there, and so A, B, C, D, and E has the same cardinality as 1, 2, 3, 4, 5. As -1, -2, -3, -4, -5. 10, 11, 12, 13, 14. They had the same cardinality, the same size, because we can show that 1-to-1 correspondence. Okay, so that's where we have to start with infinity. Talk about how can we count, how can we show something that's the same size as something else without necessarily counting all the elements in that set. And so if I had the set of natural numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to infinity, the question I want to ask is, does that cardinality, does that set of numbers, is it the same size as other infinities that we know about? What about whole numbers? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You might say that, well, the whole numbers has one more number in it, 0. And then it's the natural numbers. And so, therefore, it must have a larger cardinality, and that is actually false. They have the same size cardinality. The same thing with integers, the negatives, right? They actually have the same cardinality as the natural numbers. We can talk about what else is there? The rational numbers. Anything that can be written as an integer in the numerator, on top numerator and integer in the denominator, those have the same size. So has the same cardinality as the natural numbers. So why is that? how can we show that? That's impossible. There's no way. There's more numbers. That's how we want to think. But we can show a one-to-one correspondence. We can show a pairing between these two with the natural numbers, and so therefore they must have the same size. And this is where we get with infinity, where we lose a lot of people when they think, no, it's impossible. They can't think outside the little box and saying that, oh no, this infinity is bigger than this infinity, and we can show that. And there's a few proofs for that, which I'll get in a later on video. So that's be coming on later on, but I hope you enjoy this beginning conversation, this beginning journey in what we call infinity. All right. So thank you for watching here. You can please subscribe down below. You can also follow us on Twitter, Instagram. You can follow us on Facebook if you really want to. Yeah. If you have any questions or comments, leave them below. I'll see what I get to answer. All right. Thank you, and have a wonderful day.